I do want to emphasize that all the problems that we are looking at in this current set of videos, that is lecture 7, all of these problems we can just as well solve with iteration, that is with a for loop or some other kind of loop. And it's probably going to be more efficient to actually solve it with a loop as opposed to recursion. So you might ask, well, why are we using recursion at all? Mainly because we just want to learn how recursion works, and eventually we'll get to those problems where you cannot use iteration. The only way to solve some problems effectively is through recursion. You'll see situations where if you wanted to solve a problem using iteration, it is going to be really hard, whereas to solve the same problem using recursion is very easy, it turns out. So there is a lot of power in recursion. We haven't actually seen all of the power of recursion. We're just actually learning recursion. So you can try this out. Try adding up the values of all of the elements of an array. You can just set up an int array. And so what you want to do is sum up. Let's say you have an array going from 0 to n-1, so it has size n. And the way to do that is to add up a sub 0 plus a sub 1, a sub 2, so on, up to n-1. You can write a loop to do this, I hope. You should be able to at this point. And notice that when you calculate the sum of a sub 0 to a sub n-1, that is, you can rewrite this as the sum from a sub 0 to a sub n-2 plus the last thing in the array. And so on. This a sub 0 to a sub n-2 can be represented as the sum from a sub 0 to a sub n-3 plus a sub n-2. Okay, so make sure you can do this. You should be able to pass an array as a parameter, as an argument, into a function that takes an array as a parameter, and you should be able to add it. Remember our discussion about arrays. We said that whenever you pass an array as a parameter or as an argument into a function, you also want to pass in the size of that array. Remember that. So you might want to think about that, and definitely if you get stuck, you can call me or talk to me, stop by my office or ask me in class, and I can go over how to do this. That is summing up all the elements of an array using recursion. Other things that you might want to try out: write out a string backwards. So let's say you have a string variable a, and we actually haven't looked at strings, so I would say treat this as an array of characters. So just treat it as an array, and we should be able to write it backwards. How do we write all the elements of all the characters in an array A backwards? We write a sub n-1 first, then we write a sub n-2, so on. We write a sub 1, and then finally we write a sub 0. So we're just writing all of this backwards. You should be able to set up a loop to do that. Given an array of characters, write it backwards. So you should be able to set up a loop, but this can be done recursively in two ways, it turns out. There's two different ways, and they're different in a very subtle way. So to write from a sub 0 to a sub n-1 backwards, you write a sub n-1 first, then you write a sub 0 to n-2 backwards. Or you write a sub 0 to write a sub 0 to n-1 backwards, you write a sub 1 to a sub n-1 backwards, and then we write a sub 0. So these look very different, but they're actually going to accomplish the same task. So definitely try this out. You don't have to stick to string. You can use an array of ints if you want to. If you're not comfortable with char arrays, you can do it with int arrays, which should work pretty much the same way. Okay, so set up an array with 1, 2, 3, 4, 5, and if everything works, your recursive function to print out the elements of the array should print out 5, 4, 3, 2, 1. Okay, So this is about the end of recursion for now. There's going to be much more later. This is a very important topic, hoping that you can just get comfortable with the recursion, because we'll definitely be using it soon.